over the answers to the assignment that you had yesterday that was all about scientific method and analyzing data and whatnot. Okay, so I'm going to start from the very beginning, and I want you to check yourself, and then there's going to be a document for you to post your final results so that we can kind of see where everybody's scoring. This was the first question, and this was about a lab, and you have eggs soaked in different substances. You probably did this in regular biology. We use dialysis tubing in our class, and we put it in different solutions, and they would either swell up or shrivel up or whatnot based on osmosis. So in this situation, they gave you the sucrose concentration that they put the egg in, the initial mass of the egg, the final mass of the egg. Then they did the math for you. They went ahead and did the change in mass, but then they also did the percent change in mass. And one of the things I want to make sure is that you notice that the percent change could either be positive or negative. And positive means that that egg gained mass, and negative meant that that egg lost mass. So a lot of you sent me some graphs, and you had them set up like this, and then you had like positive and negative, okay? That would have been okay, except that in this situation, you were taught that it should have been a line graph because we were showing some change over time. All right, so the first thing said, construct an appropriate graph, label it, label the axes, things like that. All right, so the graph should have been a line graph, okay, over here. So here is your 0, and all along here, these were going to be negative numbers, and these were going to be positive numbers depending on your concentration of solution. So the thing that the scientists changed was the molar concentration. Okay, and so your independent variable, the thing that the scientist changes, always goes on your x-axis, okay, because we've got the dry mix. So the molar concentrations that they gave us were 0, 0.5, 1, and 2. So they skipped 1.5 because you want to make sure that this is spaced out evenly. You can't skip it, okay? So your molar concentration should have been evenly spaced out your 1.5, okay? And then so this would be molar. And those are the solutions you're going to put it in. And then over here on your y-axis, the actual thing that we were measuring, we measured their beginning mass, we measured their final mass, but the thing we were actually looking at and comparing and finding the information about was the percent change, okay? Not the total overall change. We wanted, the percent change, because the percent change actually makes it even. So if you started with a big egg versus a small egg, the total change might be different, but percent change is where it evens everything out. All right, so the percent change, you had positive 4.11, and then it went all the way down to negative 13.44. So the way you separated it had to be the same above and below, okay? So if you did 1%, 2%, 3%, 4%, then you had to go negative 1, negative 2, negative 3, negative 4, okay? If you did it by decimals, that's fine. So the more exact you were, the better your graph is going to look. And then you plot your points. So for the 0 molar, it gained 4.11, so somewhere up here. At the 0.5, it lost 2, a little over 2. And then 1.0 lost around about 7. There is no point for your 1.5, so you skip it, and then this one goes all the way to somewhere down 13. So mine is not beautiful. Yours should be a whole lot better. And then if you connected the dots, it's going to be a little crazy, but if you do your line of best fit, okay, that should help you. And mine is not perfect, so yours should be measured out nice and neat, because what we're looking for on part B says determine the molar concentration of the egg. Well, I got a lot of text messages about this, and what you were doing, if you remember, you could either do line of best fit, or you could connect your two dots. The dot that's above and the dot that's below. And in this situation, it was the 0 and the 0.5. And then right here, where it crosses at 0, that stands for 0% change. And what that means is that is the molar concentration of the egg, because if it was exactly the same, you would have no change at all. So the answer to part B, if you did it nice and correct, the answer that they accepted was somewhere around about 0.3 molar to 0.5, depending on how you graphed it. So if you have an answer between 0.3 and 0.5, you are good. Now, you needed to include your units of molar, and then you need to be able to explain why, and that's because that's where it crossed the 0, 0% change, and that would be your justify. So just putting this answer is half, so you get +1 for that. So somewhere between these two numbers is +1. But justifying is where you explain that that's where it shows a 0% change, which makes it exactly the same molarity. Okay? Part C says movement of water and nutrients is critical for plants. Use the concept of water potential to explain the role of positive and negative transport. All right, the word pressure in there kind of confused some people, but you should have used your formula sheet and remembered that water potential is your pressure potential plus your solute potential. Okay, so pressure can change whether water moves or doesn't move. And so water always moves from high to low. So high water potential to low water potential, and then you had to be able to identify what's going on. So if you change the pressure, you can change the water potential. So plants do that. They can pump sugars and different things into their cells and change the solute potential, or they can pump them full of water or decrease them and change the pressure potential, and then overall it makes water move in or out of cells. And if plants don't move things in and out of cells, they're in trouble. Loss of water from a plant you could have put is because of transpiration, and it's because inside the plant is high water potential, but then outside in the air is low water potential, and so that water is always going to move from high to low, and that'll be transpiration. When it climbs up, it's going from high to low water potential because the roots are full of water in comparison to the leaves, so it's going to move that way. And let's see, the roots have positive pressure, and that causes it to push things up.